Hello, Algebra 2 students, and welcome to week 2 of e-learning. All of the problems that I'm going to be doing for you on this video, we have done in class before, either prior to spring break or we did it last week on the first week of e-learning. So this is just a review, and I'm going to go through every type of problem that you're going to see on the assignment, and your assignment is not due until Friday at 11:59. So same thing. We just have one video and one assignment for the week. We're just reviewing. Here we go. First type of problem. We want you to write each expression in radical form. That means I want a radical in my final answer. So we need to remember that the top number is the power and the bottom number is the root. And since my base is in parentheses, keep it in parentheses. So 7n is being raised to the first power cube root. So that should match the first couple of problems on your assignment. I'm also going to be going rather quickly because this is a review, so also remember that you have the opportunity to stop this video at any time, rewind it if necessary, or pause if you need to write something down. Okay, second kind of example that you will have in your homework. I want you to write the expression in exponential form. That means I want you to take the radical out. So I notice that my base living underneath the radical is an r, and the top number needs to be the power and the bottom number needs to be the root. I notice that the power is 5, the root is 3, therefore r to the 5/3 is your final answer. Next, the next set of problems on your assignment, you can do them on a calculator. I'm not going to be there to look. But I would encourage you to use a calculator to check your answer. And instead, for these questions, please get out the blue Powers That Help You sheet. That's the learning that you want to review. So when I do 25 to the 3/2 without a calculator, I have to, that was a highlight fail. Here we go. The top number is the power. The bottom number is the root. But in order to keep your number smaller, I told you do the root first. So I'm going to do the square root of 25. If you don't know that math fact, go ahead and use the Powers That Help Me sheet. The square root of 25 is 5. So I've taken care of the root. Now I need to take care of the power. And I can use the Powers That Help Me sheet to see that 5 to the 3rd is 125. Well, that was a iPad fail. All right, let's try this. Oh, there we go. All right. Next problem, 343 to the 2/3. Again, the top number is the power, the bottom number is the root. So I encourage you to take the root first. It keeps your number smaller. Because if I'm just using my blue Powers That Help Me sheet, if you try to do 343 to the second power first, I don't have that math fact. So take the root first. We're going to take the cube root of 343. So look in your cube root list. And the cube root of 343 is 7. So we've taken care of the cube root. Now we take care of the power. And 7 squared is 49. And that's how I would complete that section without a calculator. Okay, the next grouping of problems is where we have to be able to simplify your radicals into simplest radical form. Recall, you cannot have a radical in the denominator. So how do we fix that? Well, we say to ourselves, I want to multiply by the number 1 because multiplying anything by the number 1 stays itself, but my goal is to get a number under here that is a perfect square. Well, in order to do that, I can just multiply 5 by itself, but it lives underneath the radical. So in order to make this the number 1, I have to multiply by root 5 over root 5. This yields root 10 because I'm going to multiply the numbers underneath the radical together, and that means the denominator will give me root 25, and I've satisfied getting a perfect square in the denominator. So what do I do to get a final answer? Root 10 stays, that doesn't simplify, but the square root of 25 is 5. And I don't reduce because 10 is an inside the radical number and 5 is an outside the radical number, and we don't reduce those. Okay, now, when I look at number 6, While it is mathematically valid to do this, friends, you are going to have huge numbers. Don't do that to yourself. Instead, say to yourself, well, the 10 will stay, but since 72 and 40 are both underneath the radical, let's go ahead and reduce. Now, I don't know what this is going to do in the video, but unfortunately, the calculator I have doesn't go into a vertical format. It's only going to be legible on the side, so my apologies if this is kind of awkward to read. All right, so I want to reduce 72 over 40. Come on. So I want to take 72 divided by 40, and I get 9/5. Come on. There we go. So what happens is the numerator becomes 9 and the bottom becomes 5. What's going on here, guys? Remember how I told you simplify up front? Isn't that a perfect square of 3? So I get 30 over root 5. And all I have to do is get rid of the root 5. So I get 30 root 5 all over the square root of 25. The square root of 25 is 5. So this yields 30 root 5 over 5. And then I can simplify 30 over 5 for a final answer of 6 root 5. And even though that still might not be the most pleasant of problems, it certainly was a lot better than taking 72 times 40 and getting this enormous number in the thousands and trying to reduce it. Okay, the fourth root of 486. All right, you have to look at your perfect fourth roots. So we have 1 to the 4th is 1. We know that 2 to the 4th is 16. We know that 3 to the 4th is 81. We know 4 to the 4th is, okay, so you're getting the idea. You're going to need to do the calculator work to divide them. And if memory serves me correctly, all right, if I take 486 and divide it by 81. Please note, I'm not going to take a lot of time right now doing the calculator work on a video, but 81 goes in evenly 6 times. So I can break this down into the fourth root of 81 times 6. The fourth root of 81 is a 3. And the 6 stays behind. 24 8 to the third. We're in square roots, so these should be numbers you're familiar with. We have numbers like 1, 4, 9, 16, 25. I don't have to check any higher because 24 doesn't go in. All right, well, I know that 4 goes into 24 evenly. So I'm going to break that down into 4 times 6, where the 2 comes out and the 6 stays behind. But we have to worry about that variable. Well, since I am in the square roots, think of this as a times a times a. I can circle one group of 2, so an a comes out, and the remainder stays behind. So that gives me a final answer of 2a times the square root of 6a. All right, next we have some properties of exponents. As a reminder, all you have to do is remind yourself, when do I add, when do I subtract, and when do I multiply my powers? So as a reminder, if I have x squared times x to the third, that's when I add. When I have like bases being raised to different exponents. If you see a fraction bar, that's when you subtract. And I multiply when I see stacked exponents. So I'm going to multiply 3 times 2 times 2 together. So 3 times 2 is 6, 6 times 2 is 12. And this is where some of you messed up on your quiz when we were back in school. Don't forget there's a 1 there. So I'm going to add the exponents because they follow this pattern. Nothing is stacked. So I have 1 plus 0 plus 2. So I get a final answer of 12r to the third. All right, friends. I gave you a doozy on this one. on purpose because this is really not hard. All you have to decide is, do you add, subtract, or do you multiply your powers? All right, here we go. So if I take this 4/3 raised to the 5/3, they're stacked. I'm not going to use my calculator to show you how to multiply them, but get a calculator, multiply them together, and I'm going to get you to the 20/9. All I'm doing is multiplying the top numbers together and multiplying the bottom numbers together. Same thing, 1/2 raised to the 5/3, they're stacked, so that means I have to multiply, and I get 5/6. This u, I'm going to multiply, that's going to give me 25/12. And when I multiply the v's, that gives me 15/12. So now what do I do next? When you look at the u family, you're going to add those fractions together. So I need to take 20/9 plus 25/12. I need to take 20/9 plus, I already forgot what it was, 25/12. And we get 155/36, and friends, that is the correct answer. Now that's just for the u's. Oop. So we have u to the 155/36. That seems outlandish, but that's correct. But now, friends, we need to talk about the v family. And the v family, I have 5/6 and 5/12. Again, it follows the pattern of I have to add them. So I need to add 5/6 and 15/12. So I need to add 5 divided by 6 plus 15/12. And that gives me 25/12 as my exponent for v, and that is correct. So final answer is u to the 155/36 and v to the 25/12. All right. Now that was all review prior to spring break. This is what we did last week. We need to solve these equations and check for extraneous solutions. Okay, let's look at number 11. Since I am in the square root mode, I'm going to undo the square root by squaring. So this gives me 72n is equal to n squared because the square and the square root cancel. But friends, this is a quadratic. And if I want to solve a quadratic, it has to equal to 0. I think it's advantageous to keep n squared positive, so I'm going to subtract 72 and add n to both sides. Then I'm going to write it in descending order, so I have n squared plus n minus 72. I need to find two numbers that multiply to negative 72, but at the same time add to 1. And those numbers are a positive 9 and a negative 8. So when I factor, I get n plus 9, n minus 8. Then I'm going to use the zero product property so that n plus 9 equals 0 and n minus 8 equals 0. So I get possible answers of n equals negative 9 and n is equal to 8. But I have to check my answer. So for the check, my original problem is the square root of 72. And I'm going to check n equals negative 9 first. So 72 minus a negative 9 equals negative 9. You can use a calculator, but this is going to give me the square root of negative 1. And unfortunately, 9 does not equal negative 9. So that means negative 9 is not a solution. That's extraneous. Again, you don't have to write the word extraneous, but it is an extra solution that comes out of the problem. You did nothing wrong. Now I'm going to check 8. And when I check n is equal to 8, I get 72 minus 8 is equal to 8. That's the square root of 64 equals 8. 8 equals 8. So that is my solution. Okay, on this problem, I have a square root. So in order to get rid of it, I'm going to square both sides. On the left, that's the easy part. We end up with 7m minus 26. On the right side, however, you have to write that twice, and we're going to have to FOIL it out. So I get m squared minus 2m minus 2m plus 4. Friends, this is a quadratic. A quadratic has to equal 0. So I'm going to subtract 7m and add 26 to both sides. So I get m squared. You can use a calculator to combine those terms, but negative 2 minus 7 gives me a negative 11. And then 4 plus 26 gives me 30. I need to find two numbers that multiply to give me 30, but when they are added together gives me a negative 11, and that would be negative 6 and negative 5. Now I'm going to use the zero product property so that m minus 6 is equal to 0 and m minus 5 is equal to 0. So when I add 6 to both sides and I add 5 to both sides, I get m is equal to 6 and m is equal to 5. Now we need to check our answers. So when I go to check m is equal to 6, I get the square root of 7 times 6 minus 26 equals 7 minus 2. Well, if I take 7 times 6, that's 42. Again, you can use a calculator. And this is going to give me 42 minus 26. That gets me 16. Come on. Okay, and you guys, I have a copy error. Hold on, I have a copy error. And I just got through this, so I'm not going to redo this at this point. That should have been a 6, so this should have been a 4. My apologies. So I get the square root of 16 equals 4, 4 equals 4, and that checks. So m equals 6 is a solution. Now let's check 5. When I want to check 5, I'm going to have the square root of 7 times 5 minus 26 equals 5 minus 2. So that's 35 minus 26 equals 3. Again, you can, the work that I'm doing on here, you can do on a calculator. I'm just trying to save some time. And friends, on this problem, they do both work. You have two solutions. So that's why it's imperative to check. Sometimes you will get one solution like we did in problem 11, and sometimes you will get two like we did in problem 12. And this concludes our last problem. And so now you should be able to do all of the problems in the problem set I assigned for the week. All right, friends, when I look at this, this is not isolated. If you think about it, it is k to the power of 3 square rooted minus 1. So I have to add 1 to both sides, and I get 729 is equal to the square root of k to the third. So what do we do to undo it? I square both sides. Now I know this is going to be a really big number. All right, when I look, 729 to the second power gives me 531,441. 531,441. Hopefully I remember that. 531,441. But what am I going to do in the next step? In the next step, I'm going to cube root both sides in order to get rid of that. So when I take the cube root of that number, all right, so when I take the cube root of 531,441, we get 81 as a final answer. All right. Thank you for hanging in there with me. I'm hoping each of these examples on this page have helped you to complete your work. And please remember that you can visit me in office hours at 10:30 every day on Zoom if you have any questions. So you have one assignment due by Friday. It is a little lengthy because it is a review, but not all of the problems will take a long time. But you do have a Unit 6 lessons 1 and 2 review due to me this week. Cheers, everyone.